ഓക്കെ, ശിവനോട് പറഞ്ഞാൽ മതിയോ? പറയല്ലേ തുടങ്ങാന്? സാറ് പറയണോ അതോ ഞാൻ അവനെ വിളിച്ചാൽ മതിയോ? ഓക്കെ, ശരി ശരി ശരി.
Hello, am I audible?
No. Here. Yeah, Shibin, you're audible.
Okay. A very good morning to one and all. So let us begin. We all are passing through tough times, and may the Almighty ease the testings and help us recover mentally, socially, physically, and economically. I welcome you all to the National E-Conference of Department of Civil Engineering, MES Kuttipuram, starting from today, the 16th of November to 20th of November 2020. A National E-Conference on Current Outlook of Civil Engineering 2020, or COCE 2020, aims to provide an opportunity for academicians, technologists, entrepreneurs, the engineering communities, and students to put forward their ideas and findings related to recent trends in the area of civil engineering. It is going to be a wonderful platform for the delegates to exchange their experiences with renowned plenary and featured speakers.
It's now time for the welcome address. I invite Dr. Syed Jalaluddin Shah, the Professor and Head of Department of Civil Engineering of MES Kuttipuram for the same.
A very good morning to one and all. Respected General Secretary of MES, Professor P.O.J. Lebba, Principal Dr. A.S. Varadarajan, members of the Conference Advisory Committee, invited speakers, heads of departments, faculty and staff members, delegates, students, and friends. Conferences, as we know, are meant to bring together like-minded people who can share their knowledge, learn, and network for mutual benefit. The world of civil engineers is highly dependent on social interaction. Since this is necessary for the advancement of the civil engineering practice, this conference has been organized even in the present conditions through the electronic mode. On behalf of the Department of Civil Engineering, MES College of Engineering, Kuttipuram, I would like to welcome you all to this National E-Conference on Current Outlook of Civil Engineering COC 20 from the 16th to the 20th of November 2020. I hope you have a great knowledge-enriching experience in the coming 5 days. Thank you.
Thank you, sir. We'll now have the presidential and inaugural address by Professor P.O.J. Lebba, the General Secretary of MES. Sir, please.
Am I audible?
Yes, sir.
So, Today's keynote speaker, Dr. Anil Joseph, I hope he is present, and our respected principal, dear Dr. Jalaluddin Shaw, Dr. Munira, Professor Ambali, distinguished faculty and delegates. I am happy and proud that the Civil Engineering Department of the MES College of Engineering has taken the challenge or the initiative of organizing an national e-conference on current outlook of civil engineering. And I congratulate the team headed by Principal and Dr. Said Shaw. I am told that this conference provides opportunities for entrepreneurs, scientists, and academicians to put forward their innovative ideas and their modern trends in the civil engineering profession. The delegates have a wonderful opportunity to interact with highly qualified experts in the areas of construction management, geotechnical and environmental engineering, structural and sustainable construction technology, and transportation and GIS applications, and water resources and offshore engineering. As you know, civil engineering can claim to be the mother of all engineering sciences, because initially, along with military engineering, came to existence in India. The earliest branch, we can say. Now the civil engineering and the military engineering then have now diversified into hundreds of new branches of engineering. You know, the Roorkee College of Engineering, College Civil Engineering, which later renamed as Thompson College in 1854, seems to be the oldest institution of higher learning in civil engineering. Now, of course, the Roorkee College has become an IIT Roorkee. These engineering courses are undergone very rapid and changes, so that very new generation courses in plenty, so that the people have got opportunities to learn the modern trends in civil engineering. Now, I am so happy to say that the civil engineering construction and construction materials have undergone revolutionary changes in recent times. The civil engineering marvels all over the world are standing monuments of the wonderful development of civil engineering and technology. You know, the metro rail, the high-rise buildings, then suspension bridges, the Konkan Railway, the old buildings, or rather like Taj Mahal, then Eiffel Tower, then the Burj Khalifa in Dubai, and many more. I am not naming all those things. So these are all real marvels of civil engineering. And we can be happy, or the civil engineer can be proud that these buildings, or rather structures, have come up from their brain. As you are going to listen to expert lectures, of course, I do not wish to take your time further, but I wish to remember that our Indian engineer, M. Vishwashraya, who was educated actually at College of Engineering, Pune. And of course, I don't know whether you know that a statue of Vishwashraya is there in the front side of Pune Engineering College of Engineering, Pune, which is one of the very old institutions in India. Then, of course, Kerala, I also wish to remember, at least to appreciate the services rendered by E. Sridharan, is our civil engineering expert. Then, of course, there are many more to name, but I am not getting this opportunity to do that. But I only wish the conference all success, and I am happy to declare the conference duly inaugurated, and wish the delegates a good time. A 5-day program, maybe a little tough, I know, but I think they will appreciate that they are going to learn a little more, much more than what they thought. And I am sure that after the conference, you will become wiser, and your knowledge will definitely improve. And we once again congratulate the organizers for this wonderful effect. I thank you very much for having given me the opportunity to preside, and I also duly declare the conference inaugurated. Thank you very much.
Thank you, sir. Next, I invite Dr. A.S. Varadarajan, sir, for the principal's address.
Am I audible?
Sir, you are. It's clear.
Yes.
The respected General Secretary of MES, Professor P.O.J. Leblanc, and the keynote speaker, Dr. Anil Joseph, Director, Geoconstruction Private Limited, Dr. Jalaluddin Shah, Head of the Department of Civil Engineering, Dr. Indira, the coordinator of this conference, and Professor Ambuli, heads of the department, colleagues, participants, delegates. I wish a very good morning to all of you. I am immensely glad to be here today for the inaugural ceremony of the 5-day National E-Conference on current outlook of civil engineering on from 16 to 20 of this year. Actually, a technical conference of this kind can be rated based on the parameters like the theme of the conference, the relevance of the theme in the present day world, the academic, professional, and commercial relevance, the topics covered and its multidisciplinary content, the panel of resource persons and the keynote speakers, the course, the cross-section of the participants, and the duration of this program. I am sure that the conference will come on the top with reference to all the above parameters. The very theme of the conference lays a hand on the advancement in the field of construction, design, and the performance of civil engineering platforms. The theme has got tremendous academic, professional, and commercial relevance, and the mix of topics covered in the conference are highly relevant in the present day scenario in the construction technology. The conference is not simply focusing on construction technology. There are also papers on topics like virtual reality, energy accounting, disaster management, subsurface drip irrigation system, etc., which represent different other related areas of technology and underline the interdisciplinary or multidisciplinary content of the conference and offer a platform to professionals and participants of different sections related to disciplines that are relevant to their field of application to come together and share their expertise for mutual benefit. The conference has got an array of keynote speakers across the country who are well known in their field for their contribution, which add tremendously to the worth of the conference. We have with us Dr. Anil Joseph, Director, Geoconstructions Limited, Private Limited, Cochin, Dr. M. Roshan Khan from IIT, Bombay, Dr. Midun Mohan from NIT, Surathkal, Dr. Suresh A. Karta from IIT, Guwahati. I take up this opportunity to thank them all for spending their valuable time with us. Now, a few words about our institution. MES College of Engineering is a 25-year-old institution belonging to a 150-member MES group of institutions consisting of professional colleges, arts and science colleges, higher secondary schools, and a medical college also. The institution offers 8 UG and equal number of PG programs. It is an institution recognized by the AICTE, and all the programs have been accredited more than once by the National Bureau of Accreditation. That has tremendously increased its credibility as a premier technical institution in the state. The institution is in the process of NAC accreditation now. MES College of Engineering actually has got an innovation center that integrates the research initiatives of the institution under one roof. It has got an educational technology center to evolve scientific methods in teaching and the learning process, a community service center to make available the expertise of the institution to the society through a cluster of 50 schools and 10 polytechnic colleges around the institution, and a training academy that offers training program to teachers in other institutions. The institution has concluded an MOU with AIT Bangkok to facilitate overseas collaboration and the ICT Academy for research collaboration. The unmanned soldier assistance vehicle AIDA, developed using the facilities of the MES Innovation Center by a team of students from EEE department, won the championship in the India Druze Expo conducted by DRDO, in which 1,888 institutions, including IITs and NITs, participated. A solenoid valve controlled prosthetic leg developed by the team of students of Mechanical Engineering Department won international acclamation. And the Bandicoot robot developed by the Gen Robotics venture of a group of alumni of the Department of Mechanical Engineering received global recognition. MSME has recognized the institution as an approved TBI, and 7 projects have been submitted in the first phase for award of grants. I would like to conclude with a quote, Tasmat Yogaya Yujyasva, Yogaha Karmasu Kausharam. This means Karma Yoga is actually the process of attaining perfection in one's profession or what one accomplishes. Contemporary domain knowledge is the most important ingredient for attaining perfection, and this knowledge can be acquired by reading, listening, asking, and sharing. And this conference is sure to facilitate all these agencies. This 5-day e-conference is sure to act as an uninterrupted source of knowledge, like an UPS in the electric system, and offer a platform to all the participants for congregating expert knowledge that will help them in attaining more precision and more meticulousness in their profession. I take up this opportunity to appreciate the efforts of the coordinator, Dr. Muniram, the head of the Department of Civil Engineering, and his team that have put tremendous efforts in making this conference a reality. I extend a very special welcome to all the participants belonging to other institutions, as they are our respected guests or Adidis, as for the proclamation Adidi Devo Bhava, and in accordance with the very tradition of MES College of Engineering, Kuttipuram. Thank you.
Thank you, sir. And now we have the coordinator's address. I request Dr. Munisha CP to present the message.
Hello, am I audible?
Yeah, you are audible.
Yeah, a very good morning to one and all. Respected General Secretary of MES, Professor P.O.J. Lebba, Principal Dr. A.S. Varadarajan, members of the Conference Advisory Committee, heads of department, faculty and staff members, delegates, students and the Department of Civil Engineering, MES College of Engineering, Kuttipuram, is organizing a 5-day national e-conference on current outlook of civil engineering. The conference aims to provide an opportunity for academics, technologists, engineers, and students community to put forward their innovative ideas and findings related to recent trends in areas of engineering. We are conducting this 5-day conference under the stream of construction engineering, environmental engineering, civil engineering, transportation engineering, and water resource engineering. Keynote speakers who are extremely passionate and knowledgeable in their areas of expertise have favorably responded to us. We have had an enthusiastic number of technical papers submitted, and keynote speakers are coming up. It is going to be a wonderful platform for the delegates to exchange ideas and listeners to have an upgrade of their knowledge. Lastly, I, on behalf of entire engineering department of MES Engineering College, Kuttipuram, would like to extend my sincere gratitude to our MES Professor P.O.J. Lebba for the presentation and inaugurational address. I would like to thank our principal, Dr. A.S. Varadarajan, for the principal address. I also would like to thank all the keynote speakers and presenters for their upcoming sessions. I also take this opportunity to extend my deepest sense of appreciation to all the committee members to make this conference happen. Thank you all. Thank you.
And now it's time for the vote of thanks. For that, I welcome Professor Ambali S.
Am I audible?
Yes.
Please.
Good morning, respected dignitaries. It's a great privilege for me to deliver a vote of thanks on this prestigious occasion. I would like to thank beloved MES General Secretary, Professor Piyojal Ebba, for inaugurating the national conference and giving a motivating presidential address. Thank you, sir. Next, I would like to thank our respected principal, Dr. S. Varadarajan, for his principal's address. Thank you, sir. I would like to thank our today's keynote speaker, Dr. Anil Joseph, for finding time in his busy schedule to deliver the keynote address. Wholeheartedly, I would like to thank our HOD for his support and guidance for organizing this event. Sir, you are an exemplary person, and thank you for assisting and encouraging all of us. Last but not the least, I would like to thank my colleagues and dear students for their constant support and cooperation for making this event a grand success. Thank you. Have a nice day.
Thank you, ma'am. Now we'll have the keynote address by Dr. Anil Joseph, the Director of Geostructural Private Limited, Cochin. I call upon our HOD, Dr. Saeed Jalaluddin Shah, to welcome him.
I am really happy to have Dr. Anil Joseph with us today. He is one of the leading structural and geotechnical consultants in Kerala, who has contributed his expertise in many major civil engineering projects within and outside the country. He's probably one of the experts who's probably done the maximum number of the consultation in the recent times. So we are really fortunate to have him today for delivering the inaugural keynote address on a topic of great relevance. On behalf of the Department of Civil Engineering, MES College of Engineering, Kuttipuram, I would like to welcome Dr. Anil Joseph for the keynote presentation in the National E-Conference on current outlook of civil engineering. I call upon Ms. Ravina C.K. to introduce the speaker to the audience. Thank you.
Good morning, all. It's my pleasure to introduce keynote speaker of the day, Dr. Anil Joseph. Dr. Anil Joseph had done his graduation and post-graduation in civil engineering from NIT Surat. He was awarded PhD from Open International University on his work on pre-stressing and hollow shell technology in earthquake-resistant construction and on pre-compression of soft marine clay from NIT Calicut. He is the director of Geostructurals Private Limited, a leading foundation and structural consultancy firm based at Cochin. He has provided foundation and structural consultancy for more than 2,000 high-rise structures, including many landmark, multi-story, and infrastructure projects in India and abroad in the last 28 years. A few of the projects are Bridge for Commonwealth Games at Kuala Lumpur, Malaysia, Apartment for Emirates at Dubai, Nurjit Heights, Bible Tower, Thrissur, Valarpadam Church, Toyota showrooms across Kerala, IT Park for US Technology at Trivandrum, Technopark at Kundra, Leela IT Park at Kakanad and Mangalore, pre-treatment plan for Paradise Limited, breakwaters and berths for Goa Port, berths for Tattadi Port, indoor stadium for UC College, etc. His design of Nippon Toyota showroom at Kalamassery and Platinum Mall at Mairadu has won the Outstanding Concrete Structure of Kerala in the building category by the Indian Concrete Institute in the year 2012 and 2017, respectively. Also, the design of Lulu Grand Hyatt Hotel and Convention Center Bolgatti Island, Kochi, won the ICI Ultratech Award 2018 for Outstanding Concrete Structure of Kochi in commercial category. Also, Noel Mattatara Heights, Kottayam, won the Special Jury Appreciation of ICI Ultratech Award 2018 for Outstanding Concrete Structure of Kochi Center in residential apartment category. He is also the managing director of Seacons Private Limited, a construction firm specialized in the execution of pile foundations and construction of churches, tanks, complicated structures, etc. He is also the director of Engineers Diagnostic Center, a firm specified in geotechnical investigation and designs and retrofitting works. He is a National Executive Committee member of the Indian Geotechnical Society for last 8 years and is representing India in International Technical Committee TC 220 on field monitoring in instrumentation and geomechanics, and in Asian Technical Committee ATC 8 on smart observation methods. He is the member of State Committee in Institution of Engineers Civil Division, Executive Committee member of Institution of Engineers Kochi Local Center, the immediate past president of Association of Structural and Geotechnical Consultants Kerala, Vice Chairman of Indian Concrete Institute Kochi Chapter, immediate past state president of Graduate Association of Civil Engineers, the past president of Association of Piling Specialists Kerala, honorary secretary of Indian Geotechnical Society Kochi Chapter, executive committee member of Builders Association of India Cochin Chapter, member of Association of Contracting Engineers, member of Reka Club, member of the Engineers Club Cochin, and an adjunct faculty of Albertian Institute of Science and Technology Cochin. Dr. Anil Joseph is also involved in various social activities such as Vice President of the Regional Sports Center, Kadavantara, Cochin, Past President of Rotary Club of Cochin Downtown, District Secretary of Rotary District, Joint Secretary of Camcare Foundation, etc. Sir, I request you to address the gathering.
Very good morning, everyone. And first of all, I would like to thank the organizers for inviting me for this program. And I wish all the best for the conference. It's a 5-day learning experience, and I wish all the best for the participants of the same. I would like to thank Ravina Ravi for the introduction, and would like to acknowledge our Jay Leva sir for the chief guest of the day, and A. Varadaraja Ravi sir, the principal of MES College, and my close friend Said Jalaluddin Shah, who is a role model in the foundation engineering and so actively participating along with this right from his younger days. We have been seeing in the field, quite active and dynamic in the field, the professor and head Said Jalaluddin Shah, and all the participants today. It's a great pleasure for me to give this keynote address to this August gathering. Let me share this talk. This will be on a demolition of the living structures, where we have been entrusted the job. Most of you might be aware that in this year, January 12th and 13th, we had the demolition of Marad apartments, which was an order issued by the Supreme Court to demolish certain apartments which have violated the CRZ norms. So in this particular task, I had 2 roles of functioning, where I was involved as the structural engineer who had designed this building in 2006 for the builders, and 4 out of 5 buildings was designed by me. And then when this demolition task came up, government has appointed me as a structural engineering expert to get it done. And when we were entrusted the task, we thought that it is not practically possible to get it demolished without environmental hazard and problems to the neighborhood. I will explain what was the problem, what was the problems envisaged, and how we overcome the problem. And it was also a challenge, because I took us the task with the knowledge which I had. We thought that it is practically impossible to demolish it, and we wanted to ensure that all the neighborhood is safe when we are getting it done. So that is why we entrusted the task by the government to take up the job. So I will take you through this process, what has happened during that time. And till that September 2019, I also strongly believe that the practical demolition of these structures is not possible. But in the course of the 4 months period, where we had an interaction with some of the experts in the world who are into this industry, I came to know that the civil engineering, there is another line of demolition, and as engineers who are doing the planning, we should also start thinking about decommissioning. The same thing which is happening for the Mullaperiyar River dam right now. So its lifespan is over, but we don't know how to decommission it, because nobody has thought of that. So as young engineers who are planning for the future high rises and the structures, we should also have the thought process of how we can demolish it without having, when it comes, if decommissioning is needed, how we can decommissioning it has to also be thought of. So I will start sharing the presentation now. Can the screen be seen?
Yes, it is seen.
Okay. So this is what we were talking about, demolition of living structures, Marat. A review is what we would like to do, what exactly has happened. And it was a emotional moment at that time. But before that, let us understand what is the engineering behind demolition. And there is a new technology called demolition by implosion. So how we can do implosion and how can we apply the technology of implosion to get the demolition done. And I will tell the background and timeline, why it happened and how it happened. Quite strange things happened, and if something has to go wrong, as per the Murphy's law, it goes wrong. So that was what happened in this particular case. And what are the challenges in demolition of the apartments and typical layout for implosion, and how we did the calculations and how we worked with the team from South Africa to get it implemented on the paperwork. All the calculations were, designs were discussed, reviewed, and finally it was approved by us, converting drawings to field execution at Merit. And that is what is most important as engineers, because our engineering is the one where we'll apply our knowledge into practice, and we will have a review of the Merit demolition in the next, say, 50 to 55 minutes of time. So engineering.
Sir, excuse me.
Yeah.
So the screen, I think the presentation is not there. It is just blank.
One second.
It is showing presenting, but.
Yeah. Is it visible now?
Yes, yes.
Okay. So this is where I was telling the content of the presentation and what is the engineering behind the demolition. And demolition can be defined as dismantling, razing, destroying, or racking any building or structure or any part thereof by pre-planned and controlled manner. When a structure is to be demolished, it must be seen that the method adopted is such that it takes minimum duration, produce less noise, cause minimum pollution, and it should be within the permissible limit and does not disturb the activity of the neighborhood and is economically viable. And the demolition method is selected after pre-demolition work, such as we do surveying of the entire area, removal of hazardous material, and a stability analysis report will be worked out. And the demolition also varies with the type of structure, structural member, demolition range, rural or urban area, and frequency. Is the screen visible now?
Yes, sir. Now it is.
Okay. The application of method of demolition depends upon actual site condition and the availability of the demolition equipment. So these are the steps when if a structure has to be demolished, which might be required in the future. So as young engineers who are attending this, you should also keep it in mind that this is something which is needed now. In certain cases, due to different requirement, which I will tell what are the circumstances where we will have to go for a demolition. So first we should do a survey, then removal of hazardous material. We should have a preparation of the plan and the safety measures. Precaution to be taken before demolition. So we have to, whenever we are going for a massive demolition like what we did, that is we demolished 8 lakh square feet of area in a span of few minutes. So that is the massive volume, and the structures which are almost 60 meters tall has to be demolished. So we have to evacuate the nearby buildings, partial or total closure of road or highway, and we have to make protective measures to the structures nearby. And what are the problems envisaged during a demolition? Possible development of cracks in neighboring structures due to what we call touchdown vibration. What will happen when this huge mass of building starts hitting the ground? There will be vibration. And induced due to sudden impact caused due to the falling of structure on the soft sensitive clay, possibility of damage due to impact on oil pipeline and petrol pump in the near vicinity. So we had a major oil pipeline running and water pipeline running close to the project area. Possibility of structural damage to major bridges which are very nearby. Site security, including the provision of fencing and barriers. And we had a big challenge controlling the spectators. We have about 20,000 people who have come in from different parts of the state and their media crew. So control of spectators and site visitors was a big challenge. Exclusion zones outside the site boundaries during critical aspect of the work when appropriate, and containment of demolished material from falling onto backwaters close by, which can lead to huge environmental damage. So what are the different techniques for structural demolition? So we have progressive demolition, mechanism of controlled demolition, deconstruction or top-down, demolition of building by wrecking ball, and demolition of building by the implosion technology. So we will just see what are the different options available. So if you see the first snap, it is the conventional top-down method where they break the building from the top and bring it down. So the cantilevers will be broken first, then the top roof slab, then the column will be removed, and it is a gradual process by which we have to remove the material. The wrecking ball is you have a huge crane, and this ball of 5 to 6 tons will be moved in, and it will be hitting the building and will be breaking the building in parts. So we have now hydraulic crushers, which is quite common now, and hydraulic crushers can go there. It can crush the concrete element and can be used for this thing. And now we have long boom hydraulic crushers available, which can go up to 30 to 40 meter high and can do the crushing process. And we have the implosion technology. So when these buildings were asked to be demolished, we suggested first we will go for top-down method, but the process takes a lot of time, and it will take a minimum of a year to complete the demolition, which the Supreme Court was not agreeing upon. And wrecking ball, we need huge cranes, and the adjacent buildings are so close by, we cannot implement this technology. The small hydraulic crusher has limitation up to 10 meters, so it's not possible. Big hydraulic crusher with long boom, yes, it can go up to 40 meters, but we have building which is 60 meters tall. So it was also not possible. So finally, to get the project implemented in this short span, we were forced to go in for building demolition by the implosion technology. So this is just a comparison of the different methodology which we made the study, how it can be done. So top-down manual method with jackhammer was there, top-down machine and hydraulic crusher. So we made the SWOT analysis. What are the benefits of that? What are the disadvantages of that? And again, for this, I just run through this because the time was the criteria which was set by Supreme Court, that Supreme Court wanted this entire thing to be completed before February 2020. So we wanted to do it before that, and the time was the biggest concern. And finally, we went for the implosion technology using explosives. So protection from noise, debris, and vibration. These are the challenges. Qualified blast aids are needed. Notification and evacuation of neighborhood. Check and cautionary handling of misfiring. And the benefits are excellent demolition strength, could shorten the demolition period and reduce labor, and risk assessment required to be continued. So we'll get into the implosion technology because used in the practice in this project. And implosion or explosion deconstruction is an effective and efficient method of deconstruction and can reduce both cost and time to bring dangerous multi-story structures to ground in comparison to conventional demolition method. Generally, dangerous multi-story building means the building is having a settlement problem, or there are many cases where the building has been subjected to fire and it cannot be maintained there. The stability is at risk. So those sort of buildings are generally demolished by using implosion. And what we do in implosion technology, we will strategically place explosive material and we will control the timing of detonation so that the structure collapses on itself in a matter of seconds. So we allow the gravity fall to happen and time it in such a way that the impact of the debris hitting the ground is controlled and the vibration is within the limit. So that's the technology which we have to put into practice. And it is a very sensitive thing because if one calculation goes wrong, everything can get into trouble. So the technique weakens or removes critical support so that building can no longer withstand the force under its own weight and it falls down. So what are the different steps involved in this? So it consists of pre-weakening of the structure, and we remove the weight of the, reduce the load of the structure by removing the infill material, strategy in placement of explosive and time delay, so that the building will collapse in a safe manner. And pre-weakening of structure include cutting of portion of shear walls and other structural elements, removal of the load-bearing non-load-bearing elements like the partition walls. The brick walls were removed to minimize the dispersion of building debris into adjoining land after implosion. A trench or bund wall shall be installed outside the building so that the vibration doesn't carry and it will contain the debris. A good design will cause structure to fall towards the center of building or within the protected area. So it has to be planned to perfection how it can be done. So this is the implosion key concept. So central support column will be destroyed and adjoining columns will be weakened. Due to gravity, the entire mass will come down on its footprint and demolition will happen. So a good demolition will cause the structure to fall towards the center of the building. So this was where the theoretical purpose, but for the project we handled, we cannot get the building to the center because of the huge mass which has to be handled. So we have to adjust it according to the challenges we had. So this you can see that the first blast will happen, second blast will happen, and the third blast, and the building will come down. So in summary, if you from the technical engineering part, these stages of demolition can be summarized into 6. 1. Survey surrounding areas to determine if structure should fall to one side or collapse on itself. Study building plan to see where explosive can be placed. Remove toxic substances like asbestos, flammable material, glass and furniture. Remove non-load-bearing walls. Drill holes in columns and place explosives. Cover column with geotextile in order to prevent the debris flying off, and that is the most important challenge. And step 6 is to detonate. So these were the different steps. So generally for this sort of project, they go for a test blast. So before carrying out the actual building blasting, a test blast is carried out in order to ascertain the efficiency of explosive and detonators. Then the wrapping of the hole is done to ensure that explosion of the charge of debris does not fly in the air and can produce damages. So that has to be taken into consideration. For this purpose, the holes are covered with gunny bags and geotextiles and meshes placed after placement of explosive and detonators. And the charging of ballasting is done to get the building done. So we did a lot of exercise on the paperwork, studied a lot of theory and understood how it can be done. And then we had the challenges and what are the failures likely to happen during an implosion. We wanted to look in, and from the studies, so we can see that some of the implosion failures which has happened. When for demolition, the shear wall didn't fail in that case. The building overtoppled in this case. So there were so much of failures reported regarding the implosion. So we were also worried, and we came across this classic failure, the failure at Royal Canberra Hospital, where a girl of 12 years was killed during the incident, and we went through the records of that to understand what can go wrong.
Good evening. The implosion dominates tonight's special edition of Telecapital News.
We begin with the disastrous aftermath of yesterday's implosion. It's estimated a crowd of 100,000 people lined to wait.
Organisers had intended yesterday's demolition to be spectacular. They couldn't have imagined the traumatic effects it would have on the national capital. Instead of a safe, fully contained implosion, boats on the lake and crowds on the other shore were showered with debris. Shards of steel warped and twisted by the force of the blast. A 12-year-old girl was hit and instantly killed. 9 others taken to hospital with minor injuries. Even today, no one could tell why the implosion turned into an explosion.
It'll be a painstaking and detailed investigation by the police. It's largely a matter, as you'd appreciate, I guess, of structural engineering questions of physics to determine the cause of the fatality and the injuries that were occasioned.
The girl was killed 480 metres from the demolition site, nearly 10 times the prescribed safe distance set down by contractors. But today, witnesses gave graphic accounts of huge chunks of steel thrown far further than that.
Bits of metal like that flying through the air that quick. Pretty cool ball.
Commonwealth Avenue, slicing through trees and smashing a car window, or coming to rest near the Treasury offices, from where it was blown off the hospital site.
Well, Canberra Hospital, and we're lucky not to be killed by it as well.
Today, many Canberrans returned.
I think it would be foolish and unsympathetic for anyone to sit here, whether it's police, government, emergency services.
So we have seen that a girl who was standing for her, even though the secluded zone was only 50, girl who was standing on the opposite side of the river. That was another challenge which we have to make sure. So we went through a lot of case studies, how it was successfully done, where it was not done, and we decided that we have to take a lot of precautionary measures before to get it implemented. Now let me tell you the theory behind what actually happened and what led to this demolition. Marat, as many of you might know, is just 7 kilometers from Kochi Corporation, and it was formed as a Grama Panchayat in 1953 and was upgraded to a municipality in 2011. So this is the background and timeline which led to this event. In November 1986, the Environmental Protection Act of 86 was enacted in the wake of Bhopal tragedy. And purpose of the act is to implement the decision of the United Nations Conference on the Human Environment. In February 1991, a notification was issued by the Minister of Environment and Forest under the Environmental Protection Act 1986. This was for the regulation of activities in the coastal area. As per the notification, 4 categories of coastal regulation zones were identified: CRZ 1, CRZ 2, CRZ 3, and CRZ 4. So in 1996, the Coastal Zone Management Plan was introduced, and Marat, being a Gram Panchayat, was marked in CRZ 3 category. In 2006, Panchayat, without obtaining the mandatory permission from the Kerala Coastal Zone Management Authority, issued building permits to the builders in the consideration that since massive developments is happening in the area, the high density of population and the proximity to Cochin Corporation, the area can be treated as zone CRZ Zone 2. So that was the thing, the error the Panchayat did. When the application came in, they considered it as CRZ 2 and issued sanction, even though in the document it was CRZ 3. So Vigilance Department of LSGD in 2007 pointed out that the area belongs to CRZ 3 and the sanctions provided are not legal. And stop memo was issued for the projects by Panchayat. But then by that time, the builders have already done the piling and the superstructure work was going on. They have already sold the building. So a single bench of High Court of Kerala, the builders approached the court, and the court and set aside the show cause notice issued to builders by the Marat Panchayat. And the stay was given for the stay which was given by LSGD, and the work continued. The builders continued with the construction based on the injunction, and flat owners started occupying in 2010. So it took 4 years of time for the 2006 they started, 2007 this stay came in, 2007 middle they restarted, and they completed the building in 2010, and people have started occupying. That is why we call it demolition of living structures. There were 357 families living in those buildings. The municipality approached the division bench of High Court with an appeal that the building should not be allowed to construct, but it was again dismissed. The Kerala Coastal Zone Management Authority then approached the Supreme Court. The Supreme Court constituted a 3-member committee consisting of Secretary to LSGD, District Collector, and Chief Municipal Officer to ascertain whether the Grama Panchayat violated the CRZ rule. And Technical Committee found that Marat Grama Panchayat violated the rule. The existing Coastal Zone Management Plan in Kerala was approved in 1996. According to it, Marat has been marked as Grama Panchayat area and hence fall in CRZ 3 category. The most important fact was that according to the draft CSMB prepared as per the CRZ notification 2011, Marat has been moved into CRZ 2, so the building was legal. But when the sanction was given, it was in CRZ 2. And Supreme Court felt that since the sanction that was on May 8, 2019, Supreme Court Division Bench was illegal and void, and no the regularization process is not right, the building has to be dismantled. In September 6, Supreme Court initiated a suo motu case against the state government for not complying with its verdict. Hence, it issued an ultimatum to raise the building by September 20th. And a report was submitted by them. And Marad municipality issued notices to the residents of these homes. So everybody, including us, believe that it's only because there was previous cases also when it was almost 8 to 9 years, and several political parties and organizations came supporting the residents and state protest marchers. Supreme Court refused to entertain another batch of review petition filed by the residents and ordered the state government to execute the order. So you can see that this is the flight where people who were, including the film actors, were living in those buildings. Those were such beautiful buildings on the coast, and they were fighting against the demolition of their house. The people were on the street, and government has removed the power line and forced the residents to wake it out. And there was so much of agitation which was happening across. So if you see the timeline, I would like to share that there was a dharma at Marad municipality in last autumn in 2019, and I was also a participant among the dharma. As a structural engineer, I didn't wanted the building to be demolished, so we were strongly against that. And in September 27, there was so much of pressure on me. And young dynamic civil engineer just graduated from IIT Roorkee. And he ഇത് തെരഞ്ഞെടുത്ത് കഴിഞ്ഞ് കഴിഞ്ഞാൽ ഇപ്പൊ നമുക്ക് ഇംപ്ലോഷൻ ടെക്നിക്കാണ് നമ്മൾ അപ്ലൈ ചെയ്യാൻ പോകുന്നത്. ഇൻവെസ്റ്റ്മെന്റ് എന്താണ്, സ്ട്രക്ചറൽ ഇമ്പാക്ട് അസസ്മെന്റ് എന്താണ്, ചുറ്റുമുള്ള ടണ്ണാണ് ഇംപ്ലോഷന് പോകണം. അത് ഓരോ സ്റ്റേജസ് ആയിട്ട് സമയം എടുക്കുമെങ്കിലും ഒരു നില പൊളിച്ച് അത് മാറ്റിയിട്ട് അതിന്റെ ഇംപ്ലോഷൻ കഴിഞ്ഞ് അടുത്ത് ചെയ്യണം, ഒറ്റ ചെയ്യാൻ പാടുള്ളൂ. പിന്നെ നമുക്ക് 1 കിലോമീറ്റർ ചുറ്റളവിൽ എല്ലാവരും ഇവാക്യുവേറ്റ് ചെയ്യണം, എന്നാലേ നമുക്ക് ഇതിന് ചെയ്യേണ്ടാവുള്ളൂ. അതിന്റെ പ്രിക്കോഷണറി മെഷേഴ്സ് ചെയ്യണം. നമ്മൾ ഒട്ടനവധി കാര്യങ്ങൾ എടുത്തു നോക്കിക്കഴിഞ്ഞാൽ പലയിടത്തും നമുക്ക് ഫെയിലിയേഴ്സ് വന്നിട്ടുണ്ട് ഇംപ്ലോഷൻ ടെക്നോളജിയില്. ഇപ്പൊ ഉദാഹരണത്തിന് റോയൽ കാൻബറ ഹോസ്പിറ്റൽ ചെയ്യാൻ നോക്കി ഓസ്ട്രേലിയയില്. അവിടുന്ന് ഇംപ്ലോഷനിൽ 500 മീറ്റർ നീണ്ടു നിന്ന 12 വയസ്സുള്ള ഒരു പെൺകുട്ടി ഈ ഇംപ്ലോഷൻ കാരണം മരണമടയുണ്ടായി. എത്രയോ ഫെയിലിയറുകൾ നമുക്കിപ്പോ. So that was part of the interview which was given on October 6th Association, and finally we decided that anyway they need an expert advice because government demolition thing. So they have written to the government. It was decided that I will also join the team to make sure that even if the demolition is to happen, it is done. Finally on October 5th, and government order was released appointing me as the technical committee expert for demolition representing Association of. And we found that there was an SB Sarvate from Indore who has done demolition and who called the Guinness Book of Record for the maximum number of demolition of structures. So we brought him in, we discussed with him, but then his experience were all mostly on the buildings which was damaged severely and was about to fall down. He has done the implosion, and that too only up to structures 4 to 7 floors height, not anything in this scale. And not anything in this challenging, but then he was put in as an advisor to our team to understand how we have to go about that. And then in November 9th, there was a team from Edifice. It's a company who's bid for the competition, and they brought in Jet Demolition from South Africa, who were adjourned with the award for the best demolition company in the world for the last 3 years since. And Anand Sharma of Vijay Skills also came in. So they made it a big team with their support. And it was a lot of engineering discussion has happened. How the calculation to be done was cross-verified. And different meetings were conducted at different phases. And then we were a bit worried. And after studying about 1.5 years, so it was always in the news, the things were happening. We have done all the paperwork, and we were sure that the technology which they have telling is practically possible. All the calculations were done, and finally there was a lot of agitation from neighborhood because people were afraid if these buildings are falling down, their houses which are very small houses nearby might also get dismantled. Even big houses were there which was just only 1 or 2 meters away. But then we have done the homework properly, and we know that if everything goes as per our planning, the demolition can be done. And I would like to remind the young budding engineers who are going to be structural engineers of the future, which the profession which I am doing for the last 30 years. So when you are doing structural engineering, even if you design it on a higher side, you do demolition by controlled implosion with the time delay. The challenges is very high. If you put less implosion, the building won't blast. If you put more implosion, it will turn into explosion and can create damage to one or property. And again, this is a task of mixing different interview again, which was given on December 27, because there was a 16 case. Allow the people to continue, but it was not happening. Study building in the impacts in the Vara in the structural audit report. Association of Structural and Geotechnical Consulting Engineers represent preventive measures, protective measures, safety study.
ഈ ആൽഫസിന്റെയും അടുത്തുള്ള 30 വീട് പോലെ തന്നെ ഈ വീടിന് ഇവിടുത്തെ ഫ്ലാറ്റ് പൊളിക്കുന്ന കമ്പനി പറയുന്നത് ഈ വീടിന് ഒരു ഡാമേജും ഉണ്ടാവില്ല. പ്രായോഗികമായി അങ്ങനെ ഒരു ഉറപ്പ് നൽകാൻ
ഞങ്ങൾ തന്നെയായിരുന്നു ഇതിന്റെ സ്ട്രക്ചറൽ. നമുക്കൊരു 10 മീറ്ററോളം ഗ്യാപ്പ് ഉള്ളിലുണ്ട്. കാര്യം നമ്മളവിടെ ഒരു കാർ പാർക്കിംഗ് ബ്ലോക്ക് ഉണ്ടായിരുന്നു, അത് മാനുവലി പൊളിച്ചു കളഞ്ഞു. അപ്പൊ ആ 10 മീറ്റർ 12 മീറ്ററില് നമ്മൾ 10 മീറ്ററിൽ തന്നെ ഇത് അതായത് ഇത് പ്ലാസ്റ്റിക് കൺട്രോൾ ചെയ്ത് അപ്പൊ ശരിക്കും ഇത് 3 വീട് കഴിയുമ്പോൾ ഒരു 18 മീറ്റർ നില, 18 മീറ്റർ പൊക്കത്തിൽ, അതായത് ഒരു 6 നില കെട്ടിടത്തിന്റെ പൊക്കത്തിലുള്ള ഒരു കൂരയായിട്ടാണ് ഇത് വരുന്നത്. അപ്പൊ നമ്മൾ ഇംപ്ലോഷൻ ഡിലേഡ് ഡിറ്റോണേഷൻ വരുന്നത്. ഇതെല്ലാം കൂടെ ഒറ്റയടിക്ക് ഭൂമിയിൽ വന്ന് പതിച്ചാൽ അത് ഭയങ്കര നേരത്തെ പോയിട്ട് ചെയ്ത്. So that was the discussion of the theory part where we were doing, and finally it was all the day, each day was running down, and we wanted to have that implosion to be measured to understand what, because we know there will be so much of cases after the implosion, after the blasting. So we have brought in team of IIT headed by Professor Bhuminathan, who is here. Professor Bhuminathan and team was there from IIT Chennai, who was helped us in the vibration measurement, and we measured vibration at every 50-meter interval. And this is Venugopal, who was heading the explosive department, who was also helping it with the calculation regarding the explosive intensity, which has to be worked out. Now coming to the challenges in the explosion, Alpha Serene, if you see that, so these are the 2 towers of Alpha Serene, surrounded by 40 odd small houses nearby, densely populated area. Another multi-story building next to the flat. Explosion has to be carried without affecting nearby, and the water is just nearby. The plan is to make the apartment collapse between these 2 spaces in between. That was the calculation which we have done. So you can see that how close the buildings are. This is the Le Meridien Annex building which is there. This is the Le Meridien Hotel, and this is the backwaters. So these are the drawings, and if you can see the soil profile, it's very bad soil. The top 50 meter is so sensitive Cochin marine clay. So any impact which is going to happen, the possibility of heaving is also very high. So we have to be very calculative of that. Piles were going up to 45 meter, terminating in this dense sand strata. And this is the Jane Coral Cove building. It is surrounded by backwaters. Only 1 meter setback was there from the car parking block. Flat has to be demolished even while ensuring that rubble does not fall into the backwater. And there is an KCB electric power which is going nearby. And we have made the plan that the building will be made to fall towards the eastern side. And this is the planning which was done. And here you can see that. And there is a huge water treatment plant also nearby. So impact should not travel to that area also. This is the Golden Kayaloram apartment, the smallest of the building, but most challenging of that. So there we went for a different technology, which I will explain. And Angamwadi is located just 5 meter away, where the young kids are studying. Another multi-story building, 20-story building, Hira Towers, just 10 meter away. It is feared that debris will fall into backwater, and there was so much of challenge in this demolition. So here we went for a concept called split fall technology, where front portion of the building was made to fall in one direction, and the back portion of the building was made to fall in the other direction. So that was the technology which was applied. So you can see that Anganwadi building, which is very close by. This is the Hira apartments, and so much of structures very close by. And this was the last of this, and the most challenging of the lot, H2O Holy Faith building. You can see the backwaters just so close by. So actually, if they would have left about 50 meter setback, there wouldn't have been any problem. So the setback was the criteria which led to the demolition. And a house is at a distance of 1.5 meter. Right next to that is the petrol house of Bharat Petroleum. Tevara Kundanu bridge is at 10 meter away. Petrol diesel pipeline of the IOC is running through that. And we have decided to make the building fall at a particular angle. Otherwise, it is not practically possible to get the building done. So here you can see that the bridge is so close. This is the water pipeline. This is the oil pipeline. Everything so close to the building, and we have to get the building done. And another factor was the dust, which is likely to come during the implosion, and the debris fall into the water. How to do that, and how to control the cracks developing in the neighboring building. So typical layout for implosion and calculation we did. So the work was awarded to Edifice Engineering Mumbai, which intern gave to Jet Demolition South Africa for the job. And this is the Vijay Steel team by Anand Sharma, along with Sarvate and myself here in the picture, where we are doing the homework of how to get it done. And here you can see that this is the planning paperwork, where the first blast will happen in this line, second blast will happen in this line, third blast in this line, fourth blast, and we will make the building weaken this particular corner so that the building falls into that degree. And these are the primary blast floors, and these are the secondary blast floor, where we are going to remove the shear wall with additional blasting. And we envisage that a 18-meter heap of material will form. So the building won't come and hit the ground. It is due to the gravity it is falling, and one will fall on top of the other, and we'll be able to control the vibration. And these were the trenches taken to prevent the vibration from getting transferred to the surrounding area. And these are the theoretical calculations, or how the drilling has to be done in each column, and how the positions has to be done, how the sequence of the blast has to happen. Everything was done to precision. All the calculations was cross-verified. How the wall has to be drilled, how the explosion has to be placed, how the fence wire mesh has to be done, how the geotextile protection has to be done, and how the intervals of the holes. So these are ground and first floor column. And shear walls, we have more number of holes drilled, and upper floors we have less number of explosive. And these are the explosive which was used for the demolition, and it was controlled by detonators. The timing was controlled, so there is delayed detonators. So we will allow one particular area of the building to fall down, and then we'll give for the nest blast by say you can see that there is a 6-second delay here, 6.4 second delay, so that fall will happen later on. So everything was done. All the buildings in the nearby was analyzed, and we were ready for the preparation. And coming to the engineering, there are two things which is most challenging in this. What is blasting vibration generated by explosion, and the most challenging is the touchdown vibration caused by the collision of building falling to the ground, and the huge impact which is likely to happen. So these are the accelerometers and geophones which are connected to measure this thing, and the breaching charges were worked. How much is the charge required to how the blast done was worked out using this equation, P is equal to R2KC, where we know what is the type of material and what is the charge to be measured. And this is another critical formula where we were working out what is the velocity produced due to the impact of the material hitting the ground, so that we can control it. And if the velocity is less than 35, there won't be any damage. And if it is more than 80, it will give to cracking. And if it is more than 115, we will have severe cracking. So this was done by IIT Chennai. So all those steps were taken one by one, and different components were divided, and the blast was all set ready to taking. And we have converted the drawings to field for execution. So what we did, we removed the oil pipeline, blocked the oil, removed the pumping of the oil, and put water inside that. And we have done shock absorbing ditch and laying of sandbags on top of that, and groundwork measurement was measured. 7-member team from IIT was put into task, and at every 50-meter interval we made the accelerometers. And here you can see that accelerometers and geophones were placed across the area and was monitored from the car connected to that within the blast zone in the protected area. Here you can see that how they are positioning the thing. And all the buildings which were nearby, all the buildings which was in the 100-meter radius was assessed by the team of structural engineers and recorded everything, including the video recording was made, so that when a claim come up later on, we can assess that what was the condition before impact and what was the condition after impact. So this is Marat demolition day. Finally it came. So we had all those homework has been done, and finally the day came on January 11, 2001, where we had gone for the blast of H2 at 11:17 a.m. So you can see that before the tower was there, and now the tower is not there. Alpha Serene was blasted at 11:43 on the same day, and tower A at 11:46. And on next day, we did Jane Coral Cove apartment and Golden Calorum apartment. So this is the H2O apartment, which was the first to fall at 11 a.m. But at 11 a.m., what happened? There was a naval helicopter which was coming in. We were all in the control tower waiting for the countdown, but suddenly the helicopter came in the no flying zone, so we have to get it grounded before we went for the blast. So that was the delay which happened, and you can see the video of the blast when it took place. So that was the sequential failing. The building has to fall 87 degree, and you can see that. That's the dust cloud getting emerged because of the air entrapped between the floors. So that was the first demolition. This was the Alpha Serene demolition, which took second wise.
താഴേക്ക് ഏത് നിമിഷവും പതിക്കും. അതുകൂടി കാത്തിരിക്കുക. ആകാശ ദൃശ്യമാണിത്. കൊച്ചി നഗരം മുഴുവൻ, കൊച്ചിയുടെ പരിസരങ്ങൾ മുഴുവൻ, ആ റോഡ്, ജലാശയങ്ങൾ, ആ മേഖല മുഴുവൻ ഈ ദൃശ്യങ്ങൾ കാണാം. അതിന്റെ പല ഭാഗങ്ങളിലേക്ക് നോക്കുക. ആ ദൃശ്യങ്ങളിലേക്ക് വരിക. ഇതാണ് ആ ദൃശ്യം. പല മേഖലയിലും പുറത്തേക്കും ചെറിയ തെറിച്ചുകൊണ്ട് തന്നെയാണ് കിട്ടുന്നത്. താഴേക്ക് പതിച്ചിട്ടുള്ളത് തീർച്ചയായും അത് നിയന്ത്രിതമാണ്. നടക്കുകൂട്ടിയ പോലെ തന്നെയാണ് കരുതുക. മാത്രമേ നമുക്ക് വഴിയുള്ളൂ. തീർച്ചയായും അത് ജലാശയത്തിലേക്ക് കൂടി വലിയ പൊടിപടലം നിറത്തിൽ തന്നെ ഒരുപാട് മേഖലയിലേക്ക് അതിന്റെ പൊടിപടലം പറഞ്ഞിട്ടുണ്ട്. താഴേക്ക് പതിക്കുന്നിടത്ത് ഇന്നത്തെ ദൗത്യം പൂർത്തിയാകും. ചിത്രമാണ് മറ്റത് കൃത്യമായി മറ്റൊരു വെള്ള നിറത്തിൽ നിന്ന് കെട്ടിടമാണ് ഇഷ്ടമോ. ഇനി ഇതിന്റെ ഒപ്പം നിന്ന വലിയ ടവർ കൂടി താഴേക്ക് പതിക്കുന്നിടത്ത് ഇന്നത്തെ ദൗത്യം പൂർത്തിയാകും. ഇത് ആകാശ ദൃശ്യം. ഒരുപാട് മേഖലയിലേക്ക് അതിന്റെ പൊടിപടലം പറഞ്ഞിട്ടുണ്ട്.
So that was Alpha Serene getting demolished. So this was the Jane Coral Cow. The engineering was, this was the perfect demolition. So that, and this was the last demolition where we went for the split technology to save the Anganwadi building and the Hira Towers, which is a 20-story building which is close by. So you can see the Hira Tower nearby, and the Anganwadi building is protected here. So that was the for this. It was a very emotional period at that time, where this was an article written by me on the next day on the newspapers covering the entire area, stating that Enda Kunjangalalle Avar. So I was the one who designed it, and finally I was there in the control room to see that it is falling down. But then only thing which we was praying at that time was that it should not create damage to the neighborhood. And you can see that Harichandra Sai, who was leading the fight against this demolition, for representing the neighboring building, thanking us for the perfect technology which was put into use and saved all their houses. And this is the post-demolition work where the debris were removed and was converted to various use, including converting it into coarse aggregates and fine aggregates. And iron rods were taken for recycling. And review of Murad demolition. Law is above everything. Law needs to be enforced strictly on officials responsible for providing clearance, builders and contractors. Transparency of law is required. The authorities need to provide a clear picture of area under each zone, and there should be provision for public to access the information. The government and other in-charge officials should make measures to prevent construction rather than the demolishing it after construction. It is always better to avoid a problem and to find a solution after creating it. The demolished apartments were constructed with a span of 3 to 4 years, and people were living in those residences for more than 8 years. In addition to the environmental impact, sustainability assessment should also consider two other important classes of impact, namely social and economic. I know so many people who had put all their earnings in those buildings and are now in the street because of that. Considering an apartment having 1,500 square feet of carpet area in a reinforced concrete building, the wasted carbon footprint is at least about 100 tons of carbon dioxide. It could then be estimated that the demolition of 360 such apartments with a remaining life of 90 years would have same negative impact as removing 90 acres of mangrove during the same period. And this is as per the calculation done by IIT Chennai. Everyone celebrated the demolition, but we never thought once about the families who were left homeless. There should be provision for avoid demolition of 29,000 buildings which have the same violation that is there now in Kerala, which will affect about another 3.5 to 4 lakh population. Let us not waste crores of money, energy and capability just to demolish it in few seconds. Alternatives needs to be opted, rather demolition to avoid environmental impact and sustainable alternative. It took years to build, but only few seconds to demolish. Let us learn from our mistakes. So here you can see that before and after demolition, and this is the team from Mr. Joe and team from South Africa who were heading the demolition along with the IIT team. So these are the how we are drilling into the columns to put the explosion. This is the IIT team headed by Professor Bhuminathan and team. And this is the network connections and the trenches which is made to prevent the vibration getting transferred. This is the team of Association of Structural and Geotechnical Consultants who played a vital role in getting it implemented. And we were doing the pre-assessment and post-assessment survey for the government in that. And this is the team of LSGD who were also, along with the Kochi Metro people who were also from the government officials who are supporting us in the process. And this is the carbon wrapping and geotextile wrapping in order to prevent the flying debris going out. And this is the just after demolition what is happening. And here you can see how the drilling and the numbering and sequencing has been made. This is the explosive coming in and protection works being done. And this is the core team, the district administration, including collector. And this is Nehal Kumar Singh, the sub-collector, the commissioner, assistant collector, everybody who was there in team along with the structural engineering team. This is the explosive team whom we were working with. This is the team from South Africa, the ground engineers, Kevin and team who were handling it. And here is a video, last video, where we had made a bet that day, on the day one, when Mr. Joe came in and we were discussing, and finally we did a lot of study on them and decided to awarded the work to them. And I wanted to go to each site to understand and tell him that what are the challenges. And we went to this Coral Cow site and I told him that it's not practically that what are the precaution measures he has to take in order to prevent the debris from falling into the river, and he was least interested. And I was telling that why you are not planning for what exactly has to be done, and he told, I am quite sure that nothing is going to fall into the river. And I was quite surprised when I looked up, I saw a 60-meter tall building, 20-story high, and he's telling that it's just a few, the car park area was just 1 meter away from the water, and he was telling me that it's going to fall down without going to touch the river, any debris falling on the river. And I told it's impossible. And I asked him, are you sure about that? And he told, why don't we have a bet on that? So finally, the day we made a bet, and he told that you have to honor the bet once I win, and if you win, I will definitely give a party to you wherever you want. So finally it was done, and the demolition was done. And after the blast, he asked me to come down from the control room. We went there. In fact, you can see that video once. So the blast he did, and there was 3 meter setback. Perfect engineering was done, and there you can see that this is the backwaters. Not a single element has fallen into the backwaters. He got it done perfectly. And here I am honoring the bet which was given, and we have learned a lot of technology in that 3-4 months where we understood. And this is the before demolition, and this is the after demolition, and finally. Contract construction. Yes. So we'll get into the queries. Thank you all for a patient hearing.
So thank you, sir. Thank you, Dr. Anil Joseph, sir. It was a wonderful session regarding the topic, demolition of living structures. I hope everyone enjoyed it well. Now it's time for the interaction session. Now the floor is open for the discussion. So those who have any doubts or clarification regarding this session can type in the chat box now. I request the interested participants to put questions in the chat box. We can discuss this question with our honorable guest. And I also request all the participants to fill the feedback form which is already uploaded in the chat box. Please do the same. So we can wait for 2 minutes for the questions from the audience side, sir.
Sure, sure. That's one thing which we should have. We should ask questions, because then only if you ask questions, say when these guys came from South Africa, I was more than sure that it is not practically possible. So we had asked so much of questions that finally we learned the entire thing. And within a month, 2 months, we were sure that that is going to happen, at least in the paper. So that it was that we were bombarding with them with so much of questions, and unless and until we ask question, we won't learn further. Yeah, there is one question from Dis Mohanan. What was done with the tons of waste generated? One thing, the debris were, in fact, we have auctioned the debris and we have got collected about 45 lakhs for the debris. Few of the debris were given for filling for the subbase for the road, and few of them we have recycled it and converted it into coarse and fine aggregates. So there was a machine which was brought in, and I think it's a big technology which is going to come up in the market soon, where the building waste can be converted into fine and coarse aggregates. So because what has happened, we were able to do only 20 tons per day, and we had a waste of about total 70,000 tons, which was reduced to 30,000 tons before we went for the blast. So the quantity was huge. So some of them were used for refilling, some of them were used for recycling, and the entire steel was taken, and we collected about 2,000 tons of steel from the entire demolition, and that was worth about 2-3 crores of rupees.
അവര് വരും എന്ന് പറഞ്ഞിട്ടുണ്ട്. ചിലപ്പോൾ വന്നിട്ടുണ്ടോ? ഞാൻ അവിടെ മീറ്റിംഗിലാണ്. രാവിലെ വിളിച്ചിരുന്നു, അവര് വന്നിട്ടുണ്ട്, വരും എന്ന് പറഞ്ഞിരുന്നു. എന്നുള്ളത് അറിയില്ല.
The explosive, Ravina, we have a question. Won't the debris contain explosive waste chemicals? The percentage, what happened, it's a total explosion. So it was done to perfection, and it's very advanced explosive element. So it will all get converted and there won't be debris left over. And it won't have waste chemicals in that. Yeah, Shibin Binshad has this question. Will demolition be a new course or subject to be taught at colleges? Shibin, I also feel that, because there are, we have seen this particular case where people were leaving and the building had a lifespan of 100 years. It was demolished after 10 years. But then there are many cases where we need demolition. Like suppose there was a case where this jet demolition did a demolition during this process. It was a 32-story building in Johannesburg, which was subjected to fire, and it was destroyed very badly in the fire, and the building was unsafe to be kept like that. So definitely that demolition has to be carried out in order to save the building which was nearby. And if you look in Chennai also, they had a demolition using the implosion technology, but a very crude system which they adopted. but there also the foundation of the building was settling, and it was a threat to the neighborhood. So definitely in the future, yes, so many teachers are there in the forum. We should start teaching them how to do the demolition without making environmental impact. And Sajina Rahim has this question: is it possible to get recyclable materials with this type of demolition? Yes, definitely, because what happens is there is a lot of debris which is being formed, and it can be recycled. And I told you, about 2,000 tons of steel we have collected from removed from the debris and has been reused for recycling purposes. And in addition to that, lot of areas for the road work, we have given truckloads of material for the base formation of the road, which can be a good material for this. Batul Abdul Aziz has this question: will the effect of explosive vibration persist on nearby buildings? Will the cracks cause further damage for nearby buildings in future? And how to measure the extent of damage? Very interesting question. Yes, that was the most difficult challenge, and that is where we were most worried about. The explosion did cause some minor damages to the building nearby, but we have done the pre-demolition survey and we did a post-demolition survey. We have insured for 125 crores for the entire buildings which are nearby. We paid a premium of about 86 lakhs for that. We paid about 15 to 20 lakh rupees for the rectifying the damages which was happened. So the impact, everything went perfect. That is why it didn't went into damage. The vibrations were measured at every 50-meter interval, and all critical buildings nearby was having these accelerometers, and the bridges had these sensors connected to that. Then the geophones were placed at different intervals, and everything was connected to the network. So by that we will be able to know what is the impact of vibration happening at different area, so that we can extrapolate the energy at particular area. And like I pointed out in that comparative screen, if the velocity of vibration is less than 35 mm per second, there won't be any damage to the structure. And if it is more than 115 mm per second, so it will have damage. But few buildings which were very close by had impact of velocity more than 115 mm. But since the duration was very little, not much damage has happened to the structure. And whatever the damage happened, we have rectified it. The foundation of the building, Divs Mohan asked this question: sir, what about the foundation of the buildings? We didn't touch the foundation. Pile cap and piles were there, and that was one important aspect, that the vibration didn't travel much, so it was absorbed. It also helped us a cushion at the bottom to absorb that. Akhil Job Kyriakos asked the question: will the demolition cause great impact on the environment? What are the precautions to deal with the problem? Yes, we have to be because the environmental assessment was being done regularly, and they have told that what all the factors to be controlled. The noise pollution, whenever it was going up, yes, it went up couple of times. So there was notice issued by the pollution control department. So we had to control that. And during the blast also, immediately after that, we had about 4 fire engines moving in and pumping water to that. In addition to that, we had backwaters all around. We had boats placed there which were spraying water to the blast site immediately after the blast was cleared. So that was the process which was done to control the pollution getting spread. And even the factor of wind in which direction and how that is going to impact was done. The calculation was done before we finalized upon the time of demolition even, in order to make sure that it is as per theoretically the best possible time which we are selecting in order to have the blast to happen. A system, Shibin Binshad has this question again. A 60-meter high building demolition was a huge task. So how we will manage decommissioning of buildings above 300 meter? Again, that is why young engineers are here. You will come up with the technology for that, and we will learn from that. So they have done up to 120 meters building, tall buildings. But again, this depends upon the density of population and the soil nearby. We have to take the challenge. So definitely it's a matter of time. Young engineers like you will come up with the technology, how to demolish the building, which is about 300 meters. Will anything happens to the earth while demolition? Abhirami MS, yes, Abhirami, that there will be impact, and that is the most important challenge. The touchdown vibration is what we have to monitor. which we were doing with the support of IIT Chennai team. In fact, the demolition agency wanted to do that, but I told that it will be done by a third-party agency because I wanted to make sure that if there is any damage to the neighborhood, they should be made accountable for that. So that is why we did that, but we found that there is not much of damages, and wherever the minor damages, we have done the compensation. Still some minor cases are there. You know how the government machinery works. The red tapeism is still there. Couple of cases we have to sort it out. So what are the types of explosive and its quantity used for the entire demolition? And in fact, the quantity of demolition required is much less. But we went for this Orica make of explosive, which was the best available explosives in India at that time. They wanted to use some explosive, but then it has to be imported from abroad. And there was a lot of challenges to bring it within this time. So we went for Orica type of explosive, and the total quantity was about 300 to 400 kgs of explosives were used for getting the blast done for a 4 lakh square feet building. Palaniappan Srikandan has pointed out that certainly we civil engineers can be proud about the development of technology in controlled demolition. Nevertheless, are you fully satisfied with this procedure as it was destroyance of the greater creation of engineering community? Palaniappan, I do agree with you. I was the last one who was going to, in fact, in the first meeting which I had with Mr. Joe, I told Joe, I have went through their resumes and the details. I told Joe, you have a very fantastic record holding, getting 3 awards for the best demolition company in the world. But here is a big challenge. You are going to convince the person who has created it to get the permission to get it done. I will definitely value engineering more than anything, but then it will be a challenging task. I will fight my tooth and nail to make sure that it is not going to get demolished. So that was that. But end of the day, yes, the destroying the building leaves a emotional setback for us. But then end of the day, it was a job which has to be done as per the rule of Supreme Court, which is the final authority in the country. And then there are so many other environmental and human factors which was connected. A social impact was there to get it done properly. And as an engineer, yes, there is proud as well as pain both together in this particular process of getting it done.
So I think all the questions from the audience side are cleared now. So thank you, sir. Thank you so much. It's our pleasure to be a part of this session. Thank you so much.
Thank you. Thank you very much.
So I request all the participants of this session to fill the feedback form, which is already given in the chat box. So all of you, please done it. Now it's time for the vote of thanks. I invite our co-chairperson of the day, Mrs. Ramya MS, Assistant Professor, Civil Engineering Department, MES College of Engineering, for delivering the vote of thanks. So welcome, ma'am.
Hello. Hello, am I audible?
Yeah, we can hear you, Ramya.
Okay. Respected and our distinguished speaker, respected HOD, my colleagues and participants. Good morning, everyone. It's an honor for me to express my gratitude to everyone present here on this day. On behalf of the Department of Civil Engineering, MES College of Engineering, Kuttipuram, I feel immense pleasure to propose a vote of thanks to our eminent speaker, Dr. Anil Joseph, Director, Geostructurals Private Limited, Cochin, who spent time from his busy schedule to grace this session with his extremely relevant address on demolition of living structures. Mainly includes the engineering behind demolition and implosion technology, and all over detailed background of marrow demolition. Thank you, sir. It was really a wonderful session. Thank you very much for making this session interesting and fruitful. Thank you. Thank you all.
Thank you, Ramya ma'am. It's time for our second session now. I invite the chairperson of the day, Mrs. Vidya Kanagaraj, Assistant Professor, Civil Engineering Department, MES College of Engineering, to conduct the second session. So welcome, ma'am.
Thank you, Ravina. Hello, sir. Am I audible?
Yes, yes.
Okay. So, good morning, everybody. We have the technical session that is in structural and sustainable construction engineering. And we have total of 5 papers. And the first paper title is Experimental Investigation on Strength and Behavior of Steel Fiber Reinforced Nano Concrete, authored by Dr. Irshad Abdulaziz, Mirfat, Ashita, Faisal, and Kavya. The second paper is PET Bottle Concrete Block, authored by Mohammad Suhail T. and Ritika Joy. The third paper is Experimental Investigation of Steel Polypropylene Fiber Reinforced Nano Concrete, and the authors are Dr. Irshad Abdulaziz and Asmunisa. The fourth paper is Factors Assessing Sustainable Housing Affordability, and the authors Divya Mohanan and Nivedya P. Pushpan. And the last paper is an experimental study on durability of concrete using partial replacement of cement with nanosilica, authored by Dr. Irshad Abdulaziz and Naslina. So these are the papers for the technical session today. Hope you all will have a wonderful technical session today. So first, I would like to call upon Kavya to present the paper, Experimental Investigation on Strength and Behavior of Steel Fiber Reinforced Nano Concrete.
Good morning, everyone. I'm Kavya here. Am I audible to you all?
Yeah, we
Yes,
can hear you, Kavya.
Thank you. So I'm here to talk upon the topic strength and behavior of steel fiber
Starting
reinforced nano concrete. So as an introduction, I would like to tell a nano concrete is a concrete that is produced by replacing cement partially by nanomaterials.
Okay, thank you.
We know